Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Try that again. And apologies to our the black box under the desk. That's it. Sean, you've got it in one. All right, let's go again. I wish to acknowledge Tasmanian Aboriginal people as traditional owners of the land and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge, the culture and hopes of Aboriginal Tasmania. And welcome to our DATV Experimenters Night. I've got Rex in the studio, Rex VK7MO. Hello, Rex.
Hi, Justin.
I've got Andrew Klekocuik,
Justin.
again, who's back in the studio. And I've also got Richard. We're pretty packed into the studio tonight, so we'll move around and try and get people in shot. So yeah, but the reason I've got all these people in the studio is we had an event, a space weather event. And I'll just highlight the very last thing I think that, or one of the last things that both Rex and Andrew said as they left for the last presentation they did on Auroral Propagation was, we're really hanging out for one of those G4 or G5 events. Well, we got a deal for you. So, across to Rex.
Okay, well, I call this spectacular auroral propagation. It was spectacular in two senses. There were certainly some spectacular photos on the web and around southern Tasmania, and we'll show some of them shortly. But it was spectacular in a radio sense, in as much as we had over 20 stations on 2 metres and a similar number on 6 metres. All using Q6515C. Some people attempted CW and SSB, but I think Q6515C came into its own, and a lot of people had a lot of fun. So we'll go to look at some of the pictures. This is the Richmond Bridge, the Convict Bridge, with the Aurora in the background from. And next slide. This is up in Devonport. I'd say that's the Mersey River. And next slide.
That's both all colours. That's
yes.
Yes.
And this is a photo that Brodie's auntie actually took, but we're attributing it to Brodie.
Okay.
And
you can come in, Murray. Open the door. Keep going.
And sorry, go back. That was
Oh, that's
and,
Brodie.
and this is Brodie's antennas with in the
Now,
background.
remind us where Brodie is.
Here's a place called Daleston, which is about 20 kilometres west of Wonthaggi
Okay.
in Victoria.
Okay. Cool.
Next slide was my grandson at Sandy Cave
Camping.
camping, and this is what he saw. So
There
that
you
was
go.
pretty good.
Wow.
Now we move on to some radio oil stuff. First of all, there was a forecast on the 9th of May that things were likely to happen.
Now, can I just point out, what's a cannibal CME?
No. Essentially what that means is you have 2 or 3 CMEs at the same time at different speeds, and they catch up to each other.
Oh, right. Okay.
And somehow they forecast that they would all arrive together and produce a spectacular aurora, which turned out to be true.
Okay.
And that was on the 9th. So if we go to the next slide, this is the sunspot. You can see that we can sort of point it out. This
The big one there.
this big sunspot is the sunspot that produced all this activity.
Now, on a scale basis, that's size of that sunspot is how many Earths?
About 10 to 12 diameters, Earth diameters, yeah. It's enormous.
Yeah. Okay.
And in fact, you could see that, I saw that with the naked eye through fog down at Kingston Beach on the weekend. You could still see it. It was moving off to the edge of the limb,
Right.
but yeah, you know,
Okay.
appropriately cautious about looking at the sun.
Yeah.
You could definitely see it.
But visible. Yeah. Wow. Okay.
Now the next slide actually shows you the Carrington Event in 1859.
So a recreation of the Carrington Event.
Yes, the Carrington Event wasn't photographed.
Mm.
The Carrington actually made a sketch with a sort of a pinhole
Okay.
arrangement, and so this is about the same size.
Oh, correct.
Although it didn't produce as big a CME or eruption,
Okay.
but it may have actually done that today. Unfortunately, it's rotated a little bit further
okay.
round.
Didn't shoot it in our direction.
No. Well, we don't know because it's only happened today, and
Yeah,
it'll be
okay.
2 or 3 days before we find out.
Okay.
But I think it's unlikely.
So of a similar size.
Yes.
Okay.
Okay.
You can see that the sunspots
Ooh.
at a slightly lower
Hang on.
latitude to the Carrington, which I think helped with the connection to the Earth. I think, you know, at this stage of the solar cycle, the sunspots are coming down towards the equator,
Okay.
and there's a better connection when they're closer to the equator, a bit later in the solar cycle.
Okay.
In fact, sometimes you can get the best auroras just after the peak of the solar cycle
Okay.
because of that.
Okay. So we've got something to look forward to potentially.
Still, yeah.
Okay. Okay.
All right. Well, next slide.
Yep.
Now, these are a bit hard to read, but what I these are forecasts by NOAA.
Yep.
And if you look at the forecasts which they put out on the 9th, 10th,
Yep.
for the 11th, you'll see it was a lot lower than the forecast for the 11th that they put out a day later.
Yeah. Okay.
It was sort of 5s and 6s and 7s, and then it went up to 9s and 8s and 9s.
Mm-hmm.
So
So how? I don't know whether this is a question for Andrew. How do they do their prediction?
So they use the coronagraphs on the Solar Dynamics Observatory,
So that's the
SDO.
two satellites. The
Well, there's a few satellites that are actually looking at the sun. So SDO's one that has a coronagraph, so it blocks out the disk of the sun. You can see the corona.
okay.
SOHO's another one.
Okay.
I think on stereo they have a stereo A. So you were talking about 2 satellites, stereo A and B.
Mm.
Fortunately, we lost B, but A is still out there. And so basically, trying to look from slightly different vantage points to look at the expansion of the coronal mass ejection, and then make some model that tells you which way it's coming.
Yeah.
But it's
Okay.
it's an inexact science because we don't have many different vantage points or viewing angles.
Okay.
If we had some more satellites out there, we'd get a more three-dimensional view.
Okay.
But still, you're trying to track quite tenuous plasma as it's moving through the solar system, and there is a delay of several days, and things can change.
Which is good.
That's right. Oh, that's right. Yeah, we're better off than Mercury or Venus, but yeah. So it's an exact science, and it's hard to estimate the density of
What's going to hit
what's
us?
happening. It's the
Yeah.
speed and density that are the key things.
Yeah,
The speed
okay.
in particular, but yeah. So in the future, hopefully, we'll get some better observatories out there.
Okay. Okay. Cool.
Because there's a lot of hardware that depends on it now. Like,
Well, and in fact, I'm going to go into something that's going to happen next week that I'm involved with that is exactly what you're talking about.
All right, next slide. Now these are the forecast. These are measured KP indexes after the event,
Okay.
and the top one is by NOAA, and you'll see that it went right to the top of the scale, which is 9. The Australian region one doesn't go as high.
Went to 8 though.
Probably 8 for a little bit, yes.
For 2.
Yeah.
Whatever the
So-
scale is.
In general, I find the Australian regions a little bit less optimistic than the NOAA forecasts. But clearly 9 is something I haven't seen since I've been involved in this stuff.
Okay. So how, from a frequency point of view, how often do we get that sort of event? Is it
a 9.
once a year, once a
I'd say-
decade, once a...
yeah, probably almost once a solar cycle. But
Okay.
Thinking back, I used to, as a lad, look through all the old records to dream about the next big event. And my anecdotal memory is that this would probably be up in the top 5 or 10 that have occurred in the last 50 years, at least, anyway, because
Okay.
in the last 50 years at least, we've had really extensive monitoring of the magnetic field, and
Yep.
so there's some really good data from the IGY, International Geophysical Year.
Yeah.
But so if people know about the K index, there's also an A index which sums up the K indices over the day, and I think it reached something like somewhere above 380 or 400, and that's a good indication that it's pretty much maximum.
And what's the highest in
Uh,
that scale? Or is it a logarithmic scale or something?
No. It's a sum of the indices. I can't recall, but it's somewhere around the 400 mark
Okay.
or thereabouts. But
So it was up there.
yes, it's certainly up there with the largest ones that have
Okay.
been seen.
Okay. Wow.
Now we'll go to the next slide, and this is another sort of index called the HP30 index, and the advantage of this is it's averaged over 30 minutes, whereas the KP index is every 3 hours,
Okay.
and so you do see a bit more sensitivity in terms of short-term variations.
Okay.
And the other slight difference is that it's not a closed, or it doesn't have a cap at 9, and in fact
That's 11.
it actually went to 11.3. So
Okay.
and I've marked there when Brodie first decoded me and when Brodie last decoded me, and you can see that it dropped down into the green when he first, and it was down at about 4 when he last decoded me.
So you're probably going to go into this, so you can tell me to hold fire. Did you see a correlation with the signal strengths that correlated with that profile?
Not so much signal strength, but in terms of a signal being there or not.
Or not? Okay.
Yeah.
Okay.
So that index is a measure of the deviation of the magnetic field. So the
Okay.
larger the deviation from the quiet condition, I
Okay.
think this is a horizontal, magnetic field component, the larger the number there, and that can extend beyond the 9, which is capped for the K index, which is for historical reasons was capped there.
Okay.
Next slide. Now, these are all the stations that in black, stations who I saw on 2 metres.
Okay.
I didn't necessarily work all of them, but I think I probably worked about 3/4 of them.
Okay. Okay.
And the red ones are stations who I saw other people working, but I didn't actually copy them, so I know they were on and active.
So there are VK2s in there?
Yes.
Is that the furthest that we got?
I think that there were certainly
VK5?
5s who were on. I didn't see any VK5s myself,
Okay.
but I saw people working
Right. Okay.
a VK5.
Okay.
So there was certainly a lot of interest,
Well and truly.
and I got 586 decodes overall.
Oh my goodness. Okay.
Now, in the past, when we've done this, basically I've just transmitted all night and Brodie has monitored it,
Okay.
and we've got useful data that way. But because there were so many on, I couldn't transmit all the time. I had to let other people have a go.
Yeah.
So, in the sense of having continuous data, we don't have it.
Okay.
But a lot of people had contacts all over the place.
Fantastic. Ralph's in there too.
Yes.
WRE. Yeah. Okay. Yeah. Okay.
Now, actually, we might just put it over to Richard, and
Mm.
he might just tell us a little bit about his experience.
Yeah.
Yeah, look, I was pretty impressed. I'd never really actually experienced the phenomena before. Look out, I'm being zoomed on. Yeah, I'd never experienced the phenomena before, and after going outside and having a look at the sky and being pretty impressed at the colours, doing the obligatory Facebook post of the pretty lights, went upstairs to listen to the radio and heard quite a few signals on 6 metres. In fact, I worked VK3MAP and VK3DUT on 6 metres with really, really good signals. So then I heard a few people calling a few CW signals and a few voice signals, but the auroral effect was really something I'd never heard before, and it made the CW really difficult to copy and the voice just impossible.
Okay.
So then I thought, well, I might as well have a listen on 2 metres.
Mm.
So WSJT defaulted to 144, 250, which I didn't hear anything. So I didn't have the 9700 on, I had the 9100, so I didn't have the waterfall, so I just tuned around and heard a fairly colossal signal. Thought, well,
That's probably Rex.
I can guess who that is. So after Rex's, I worked it out it was 15-second, sort of 15-second periods, and I sort of guessed that it might have been B mode, sub-mode B, and got no decodes. But it was, when I heard Brodie transmit, the signal was like, because Rex's was obviously clean and not affected by any of the auroral, but Brodie's was like, goodness, it sounded
And we've
most
got some
unusual
examples of that.
And it's like trying to actually tune to find the carrier is like, it was really difficult.
Yep.
But I was lucky I got onto the frequency that Rex was on and got some decodes. And then I worked Brodie and it was like really good signals. Like, I was astonished. So I think I worked 6 stations on 2 metres. So.
Okay.
But it was, I've never come across that before. It was really sort of pretty exciting.
Fantastic.
Yeah. I was pretty impressed. But there was I think there was a few voice signals in amongst there. People were saying, QSY down, sort of whatever. But
If you could understand them.
Yeah, but it was quite uncanny. I was saying to Rex earlier, it was quite uncanny that normally, if we're used to working like Troppo, you need to actually, like, obviously aim your antenna to sort of peak up and you'll find where the sweet spot is. This is like you spin your antennas and you go, have I got the Omni on? Because it's any effect, and in fact, rather than have a peak, you actually just had a couple of nulls.
Yeah.
Which was maybe where the aurora wasn't quite as intense, but Yeah, look, I was pointing pretty much southeast,
Okay.
and it was just fantastic. So
Fantastic.
that was good fun.
Thank you, Richard.
Okay, next slide. Oh,
Yeah, no, keep going. I'll just spin the...
Spin it around.
Oh, spin. Spin in the right direction. Oh, there's Andrew, yes.
right.
Cool. And we'll go back to there. That's better.
Okay, these are the stations I saw or worked on 6 metres. Again, the black are people who are actually copied,
Okay.
and the red are people who I saw other people working. So I know they were on.
Now VK1's in there.
Yes.
That's Gerard, isn't it? I think. DI. VK1. ZL3 RC and ZL3 ZLs.
Yeah.
Hello.
Now I actually worked them,
Okay.
both of those.
Yep. All 3 of them. Yeah, yeah.
I didn't work the 4th one.
Oh, okay.
I saw the 4th one. I thought there might have been a chance of working, sort of beaming towards New Zealand, and because the Auroral Oval was essentially up to Tasmania and also up to Christchurch,
Yep.
I thought there might be a chance of copying them on 2 metres by beaming direct.
Okay.
In practice, I heard absolutely nothing on 2 metres, but when I tried 6 metres, the signals were 30/9.
Okay.
They were enormous, and they weren't. There was no auroral effect on them. They were quite normal.
Copyable. No,
Co-
no artifacts.
And while I wasn't too aware of this effect before the last day or so, that it looks like there is a mode of propagation which people call Auroral-Es, which is effectively the E layer, sporadic E being sort of stimulated by all of the ionisation from the aurora.
So the aurora creates an E layer. Is that,
Well, patches of E.
patches of E? Sorry,
It's
okay.
still
Sporadic
patchy.
E.
It's still patchy.
Yeah. Okay.
And it certainly came and went.
Okay.
But when it was there was no Doppler shift.
Yep.
There's no spreading, and it was very strong.
So that effectively makes the geometry quite different. Is that what we're talking about? Because you've got a much lower layer that it's scattering off. Is that what we're talking about?
It's about the same height
Okay.
as the aurora.
Okay. So why do we get much better or less artifacts in an auroral-E?
Yeah, there must be less Doppler shifting, but I guess the E layer is maintained by that ionisation. I think also the heating by the auroral electrons coming in also helps. It creates gravity waves that create a shear in the layer that keep it intact to some extent. Now, one of the interesting things that people saw on the weekend were these dunes, features called dunes, which are at about 120 kilometres, that's the E layer height.
Okay.
And if you see some photographs, you'll see wave-like features. You'd think maybe it's cloud, but they're actually sort of brightenings in the aurora that look like a series of waves.
Okay.
And really only described in literature about 3 or 4 years ago, and photographed at sort of mid latitudes in the northern hemisphere. But actually, I reckon I saw them about 40 years ago when I was at Macquarie Island.
Okay.
Amazing kind of, just they look like waves, that you see on the ocean, but in the sky moving along, just brightenings in the background glow of the aurora. So auroral dunes. So I suspect that the auroral dunes have got some relationship here to that E layer. That's kind of an interesting bit of science to
Wow.
follow up on. But
Okay. Okay.
but there are a number of interesting things that were happening. So this E propagation, these dunes, and a few other things. But it all comes down just to the amount of ionisation that was happening. I think that's
Which
kind
is
of a key thing.
Off the show. It's
Yep.
way above what we'd normally see. Okay. Okay.
Okay, next slide. We'll get
Cool.
Andrew to talk about these.
Right,
Keograms.
so yeah, I've got a camera at home, so it's it's called an all-sky cam, all-sky camera, and about 10 years ago it was, you know, quite a neat little camera, and things have moved on. Its claim to fame is it's extremely cheap, and I'm a kind of a cheap person, so, but basically it's taking a picture of the sky every minute with a CMOS camera, so it's not super fancy, but it's sensitive enough to see aurora. And so that's the plot at the top where I've taken the column, north-south column, in the camera and then stacked it in time.
Okay.
And so that's the 2 days there, that's the 10th and the 11th, and at the bottom is some analysis of the location of the auroral oval. But before I talk about that bit, of course, stacking this column, you know, there are cloud effects in there, and this is a UT day, so the first and the last parts are actually in daytime. But around 1645, 1700 UT on the 10th, this is when the storm really started, and look closely, you can see red aurora in there, and if it's going past the middle of what's called a keogram there, which is the north-south column going from bottom to top, it's gone past our zenith. So in the early morning of the 10th, or the 11th local time, we got some very intense auroras, and folks were out there taking photographs at that time. And then the next day, as soon as sunset hit, we also had a lot of aurora all over the sky. I've got a movie of that on YouTube that people can look at. I think we've got that there.
Yep.
But at the bottom, what I do there is, we've shown this before, NOAA has a forecast of the auroral oval location. It's roughly about 30-minute forecast. It's using data from the satellites at the L1 Lagrange point upwind of the Earth. So there's about 30-minute transit time.
So they get it first. They get it
first, yeah, for a solar wind speed of 500 or 600 kilometres per second. That's the kind of the transit time, and so that model is using that information. It's kind of using the speed of the solar wind and the density, and it forecasts where the auroral oval is in both hemispheres. And what I do is I take take that data and estimate how far away the auroral oval edge is from Rex and from Brodie.
Okay.
And Rex is in blue there, and Brodie's in orange, and that's the elevation in the sky of the auroral oval edge, assuming 120 kilometre altitude, which is roughly where we think we're seeing most of the backscatter. We're probably seeing some from higher altitudes, but that's a good indication. That edge analysis is informed with some satellite data I've looked at to check to see if it makes sense, which it does.
Okay.
And we've also had a number of events where we've kind of confirmed that once the aurora gets over the horizon at where Brodie is, you can see Rex most times.
Okay.
So anyway, on the left, there was a little bit of an auroral event before the main storm hit. The black line is magnetic midnight, when we tend to see a lot of auroral activity. It comes in storms or substorms, as they're called, usually sort of early evening, midnight, and later on. Keen-eyed people there will see that the elevation scale on the left is actually quite different to the one on the right, because on the right-hand side plot there, the aurora got pretty much overhead in Tasmania, or at least beyond. Their analysis probably underestimates a bit the actual extent of the aurora in latitude, but it's an average over a few hundred kilometres, so it's probably not too bad. In fact, I've looked at some satellite images from this event, and it's actually not too bad. Okay. But you can see Brodie was seeing the aurora for quite a lot of the day there, which in fact tallies with what he saw.
Okay. We saw, so from a visual effect, I was at Sassafras on Friday night. We saw some great auroras on Friday night, but then I was back in Hobart on Saturday night to see the event.
Right.
So we did see activity on.
Oh, good. Yeah, I saw some pictures from the midnight time on the Friday.
And we were up at midnight because we were doing a checkpoint for an equine endurance event.
Yeah.
So we were up at midnight.
Right.
We were actually up because the thing started at midnight. So yeah.
Yeah, it was fairly cloudy here in Hobart, and that's if you look at my keogram there, you can't really see the aurora around midnight on the
but
early
later,
one, but later on it
well
popped
and
out.
truly. Cool. Okay. Next.
Next slide.
Now,
I think you have to click on it.
there we go.
Yeah, so this is these are 1 minute images from 7 UT to about 22 UT
Okay.
on the 11th, and you can see the cloud sort of dissipating early a bit there. There's some aurora in the background.
Ooh.
And my camera is fairly sensitive to the red, not so much to the green colour, but
Okay.
you can see it comes out white, but it's the whole sky. And one interesting thing is that in the northern sky, there's kind of this red glow, which is sort of fairly continuous.
Okay.
And I think that's another part of this auroral process where there's lower energy electrons coming in at lower latitudes that are causing this sort of glow, general glow. But there's quite a lot of activity. It comes and goes in spurts a bit. Milky Way is visible in the background. And we get some nice rays that merge at the magnetic zenith, which creates this thing called the corona, which is happening there.
Yeah.
That's right. And then later on, although my camera doesn't show it here, I've got some movies from the real time. There's pulsations happening, flickering of the aurora, which usually happens in the breakup phase. Post-magnetic midnight, we actually see some of that.
Seeing the Milky Way move.
Yeah, the Milky Way
Yep.
moving through.
Yep.
And a bit of cloud coming in later on. But it's still active at the southern part of the sky, which is at the bottom of the image there.
Yep. Okay.
And
So that's north-south. It's.
that's right.
Yeah.
And
Okay.
east is to the left.
Yep.
There.
Okay.
And the sun's about to come up, but the aurora is still going right to sunrise, basically, and that, of course, that tallies with what Brodie was seeing as well.
Well, there you go.
And you might see a few sheep wandering around if you look closely.
Okay. Right. Cool.
Okay. These are the NOAA 30-minute forecasts of the aurora.
Do you want to go?
Yes.
Okay. Push button.
The first thing to notice is here's the centre of the auroral oval, and it's well away from the south pole, which is here, and it's well away from the south magnetic pole, which is here. Now, what do you call this pole?
Well, more or less the geomagnetic pole, I guess you could say. That, of course, the thing that we're interested in is where the magnetic pole is effectively at the height of the aurora. So that's kind of, a little bit different to where it is actually on the surface of the Earth. But
Okay.
geomagnetic pole's kind of off the coast of Antarctica, sort of near Dumont d'Urville.
Okay.
And,
Okay.
and
Sorry, that's the actual magnetic
that's
pole.
the actual magnetic pole.
Yeah.
That's right. And it's this. It's in an oval because it's being pushed. Essentially, the magnetic field lines are being sort of draped over the Earth and pushed away in the nighttime sector by the solar wind pressure.
Okay. Okay.
So
Yeah,
it's
yeah.
kind of pushed away from the day side into
Yep.
the night side.
Now, you'll notice that this oval is actually towards Australia, which is very fortunate for us. That, for instance, if we were in South America, the oval would be another 2,000 kilometres away from anybody who was trying to do it. So it's probably about the West Australian border where it's would be the most, but Tasmania, of course, got the advantage we are further south than anywhere else, and we're not far off where the oval is offset. So it does enable us to use the aurora more often than one would expect.
And you fit quite a bit of the South Island of New Zealand as well.
Yes.
Actually.
Now, the next slide will be a movie of this event.
Push button.
And you can see where the Auroral-e is moving away from Australia at the moment, and that's because it's the opposite of magnetic midnight,
Yep.
if there's a word for that.
Yep.
Okay.
Magnetic moon.
Magnetic.
So that's that polarity change that we see
Yeah.
on those charts.
Yeah. So
no, you don't see it on the KP charts.
Oh no, but the charts that you showed earlier.
Oh,
that's
yes.
right. Yeah.
Yes.
So this is that diurnal change which is brought about by the day-night
Okay.
condition. Yep. So it's being pushed away from the daytime side into the night side. So the best time for us is magnetic midnight,
Yep.
when the Auroral-e is closest.
Okay.
And at the end, it sort of fluctuated quite rapidly.
Mm.
Yeah.
Okay.
So,
Keep going.
yep.
Yeah. Keep going. That's better.
Now, this is the longest contact I had with VK2DO on Aurora on 2 meters, and he's at Bateman's Bay up in a bit south of Sydney,
Okay.
and the green is the parts of the contact that I received,
Yep.
and the white background is what I sent.
Okay.
It's
It's -9.
yes.
That's
I
reasonably
think it also got a bit weaker too.
oh,
where I was-
-17.
Yes.
Towards the end. Yeah.
Now, if you look at the blue waterfall, you can hardly see any signal there at all, and the reason is that the arrow points to the actual Doppler, and you'll notice that the Doppler
Ooh, 300.
was moved so low that it was hardly in my passband.
Yeah. Okay.
And you probably can't see it, but there's a graph there. Can you see a yellow graph?
Sorry. Where are we looking?
Uh,
The. Yeah, down the bottom. Yeah. You can see that.
yeah, see that peak?
Yeah, it's a bit hard to see.
That's where my sync.
Oh, okay. Yes. You know, you can see it on the screen.
Yeah, that's where my sync tone is.
Yep. Okay.
Right down at sort of 200 to 300 hertz.
Okay.
And yet, I was still copying him.
Wow. Okay.
So,
Now you've got some recordings here as well that you want to play. Just go up
Yes.
and click one of the speakers. There we go.
okay, what dB level's that?
-9 dB, 300 hertz. Okay.
Now, the tones, well, they're down at 200 or 300 hertz. The message, that's the sync tone. The message tones are anything up to another 1744 hertz higher.
Okay.
So you're probably not hearing
Those tones.
the lower tones.
Yep.
But so all those bursts are message tones
Okay.
at higher frequencies.
Okay.
And if we go to the other one, this is a
Okay.
-17 dB.
Yep.
It's still quite clear.
I said to guess they're stronger than the -9, but anyway.
Well,
That doesn't make sense.
Why I think that is the case is you'll notice that this one, the frequency was much lower. What was that down to?
The Doppler.
Yeah, down to
217.
217 against 300.
Yeah, okay.
And what I suspect is that the actual sync tone was maybe even lower than that, and so because it primarily gets the signal report out of the sync tone,
Yep. Okay.
it got a very weak signal report
Yeah. Okay.
compared to the one that was up at 300 hertz and gave -9.
Well, there you go.
Okay.
Still pretty strong signals though.
Oh yes. Now, this is a contact Brodie had. Well, two contacts, one with VK5 and one with VK2,
Okay.
and the bottom on the waterfall where you can the bottom and the second bottom are from VK5 AKK.
Yep.
Then there's a strong patch which shows up about 1,000 hertz from VK2DO. And then there's two signals which decoded, and they're not even visible on the waterfall. There's no evidence.
No way.
The sync tone, in fact, is still about 1,000 hertz if you read it off.
Yep. Yeah. 973 and 973, 940.
And you can't see a thing, can
There's
you?
nothing there.
It's just so spread and weak, and yet it's decoding.
Okay. Righto.
Okay, next slide. Now, this was something interesting that we found out during this event. In the past, I've always thought that we never got more than about 400 hertz positive or negative Doppler.
Okay.
Obviously,
Ooh. Yeah. Okay.
and what happened was VK3KRG was listening and found that by tuning down 1,000 hertz, he suddenly started to copy me. And obviously the Doppler was well below what was in the normal passband.
Mm-hmm.
And when you look at the blue, that's where he was tuned to 0.260, the normal frequency.
Yeah.
And you can see that it seems to be cut off below 600 hertz.
That's it.
And
yeah.
what I suspect was happening is those gaps in between, the Doppler was more negative than 600
Oh, and filtered out.
and his passband
Yeah.
would be, if we transmit at 700.
Yep.
So if he's down at 600, he's only at 100 hertz, and most receivers don't work. And I think that's why the cutoff was.
Okay.
But when he tuned down 1 kilohertz, he was still copying me. And when we adjust for the fact that it was 1 kilohertz lower, we can see that the Doppler actually went
That's 1100 minus 1100.
1100 hertz low. So the lesson from this is, if you're after magnetic midnight, when the Doppler is more likely to be strongly negative,
Is tuned down.
well, apply RIT, and I think about 500 hertz of RIT will probably cover most situations.
There you go.
Now, next slide. This is all the Doppler shifts I measured over the last 12 months.
Okay.
And you can see again that everything below 600
Is cut off.
is cut off. I never picked that up, even though I'd drawn that graph and looked at it a lot.
Yes.
And
Yeah, it's one of those things. Once you get all the data together, you start to see these patterns, and we start to see that there was a bit of a
now, the odd thing is, on the top side, before magnetic midnight, most of the Doppler is plus about 350 hertz.
Yeah.
But after magnetic midnight, there seems to be two separate Doppler trends.
Yep.
And I don't know the answer to that.
No, we're still looking at that one.
Yeah.
And it's a lot more spread. It's it's sort of the full range of 600 minus 600 hertz, whereas there's clear clustering at like 300, 350.
Yeah, it could relate to magnetic activity, which tends to be, there's a bit more auroral sort of substorms happening once evening sets in. If it's in the daytime, which would be the earlier part there, it tends to be a bit suppressed, so that's possibly a factor.
Is there any comment about the fact that around midnight it's shifted, like it goes into negative before we get to midnight, and then it's primarily negative after midnight? Like there's some confusion in that middle.
Well, Rex has an idea about the...
I'm not... No, I don't think I've got an idea. Well, yeah. I think the thing is that the antennas we're using have very wide beam widths.
Okay.
So
you're looking at a large...
We're looking at a large area, and what we think is happening is there's two... The solar winds, or not the solar winds, the winds in the auroral area are driven both clockwise and counterclockwise.
Okay.
And these two cells, before magnetic midnight, you're pointing at one cell which is rotating one way, and after magnetic midnight, you're watching the other cell.
Okay.
But because our antennas are pretty wide, they're watching possibly both cells, and that's why there's a sort of a bias away from magnetic midnight. I'm not sure. It seems to go negative. Well, partly
and stay negative. It's just
a little bit earlier than magnetic midnight. Whether that's a function of where we've actually got our antennas pointed and things like that.
Yeah, another factor is so that these two cells are sitting over the pole. We don't have a diagram of that, but basically you can imagine a clockwise and a counterclockwise cell over the pole. This is in the sort of ionospheric heights, and these are the winds or the motion of the ions, and they get driven from the night to the day side.
Okay.
Now where Tasmania is, and this is another sort of interesting thing, the motion of the ions is along magnetic lines of constant latitude, which are actually inclined slightly to the geographic lines in Tasmania, and they actually tend to kind of sit from exaggerated northwest to southeast, and so there's a tendency, basically when you look at the arrangement, there's a tendency to have motion biased in one direction before midnight compared to after midnight, and we think that that's part of that. It's just the fact that we're kind of sitting in the right spot to see that, and you might see something different at a different longitude, and that would be the interesting thing for folks at other places around the southern hemisphere. Not that many.
I was thinking New Zealand, actually.
New Zealand would be interesting.
Yes.
Well, true.
That would be a good place to confirm.
And see, they're offset anyway. They're in that direction, actually.
Yeah. So that's kind of something we're looking at to try and explain that.
But I agree. Your earlier comment, you start to see these patterns when you start to put all of the data together.
And of course, we've even got some positive Doppler out in the dawn side there as well, which is, magnetic storms come and go and start up, and that could be part of the reason. What's that date on that positive Doppler in the date?
I think
near the dawn.
no, I don't think I can pick
Can't
it.
read that one. Right.
But
That's right.
But essentially, there's two effects. There's the spinning of these winds, and if they were the only effect, then you'd probably just go from 400 hertz to minus 400. But then there's the actual oval expanding and contracting, which adds the Doppler or subtracts from the Doppler.
So there's other things modulating that.
Yes.
There's okay.
All right. The next slide is one for Andrew.
Yeah, so this is based again on the auroral oval analysis. So just trying to separate out the two effects. I'm looking here at the expected Doppler from the advance or retreat of the auroral oval edge, so whether the aurora's coming towards us or going away, just based on the edge of the auroral oval. And there's a tendency, it's quite a lot of spread there, but there's a bit of a tendency for positive before magnetic midnight and negative after magnetic midnight.
Yep.
But again, there is a lot of dynamics happening. There's aurora starting up at different times of the day, but under general conditions, there's a tendency there for a bit of positive in the earlier part and negative in the later. So that's also adding into the picture here.
Okay. Cool.
Next slide. Now this is data back in March, where Brodie and I worked on both 2 meters and 6 meters at the same time.
Okay.
And you can sort of see it wasn't so good before magnetic midnight, but after magnetic midnight, you can sort of see the 2 meters is split into something about 200 hertz and something about 500 hertz.
Yep.
But the 6 meter stuff
Is not much.
is not much, and
Not much
certainly
shift at all.
the factor of 3 to 1, which you would expect from the
6
2
to
meter
2,
stuff
yep.
at the bottom,
Yep.
doesn't show up in 6 meters. I think this has got something to do with the beam widths of our antennas in the vertical plane.
Okay.
So that because 2 meters necessarily has a preference for things on the horizon,
Yep.
it gives you that wider Doppler shift,
Yep.
whereas 6 meters is always going to pick up stuff that's almost overhead because the beam widths are so high,
Yep.
and you get much less Doppler shift. I mean, if it's right on the horizon, the Doppler is twice the movement. But if it's right overhead, at least at your place, the movement doesn't have any effect on it.
Correct.
That's right.
And I think this is the explanation for why
Okay.
you can't get the 3 to 1
Ratio.
ratio.
Another possible factor is that there is a bit of a shear in the velocities as a function of height too. It's not all moving at the same speed
Okay.
through the auroral curtain, and that can be a factor there as
So
well.
do those interfaces then create other effects where there's shear?
Yes, that's right. So again, I think the sporadic E is sort of influenced by that. But
Okay.
satellite measurements have shown that there are shears happening in the velocities of the electrons as a
Okay.
function of height. That's the horizontal movement rather than the...
Yeah.
They're streaming in,
Yep.
but they're moving also with the electric fields that are carrying them away.
You talked about those waves earlier. Like that. Is that potentially a shear interface where you're seeing those waves?
That's right. Yeah. I think. Yeah.
Okay. Wow. This is cool.
Yes. Next slide.
This is physics.
Okay. Now, it was a bit of a surprise to me when I beamed at ZL. I suddenly saw these very strong signals without any Doppler shift on 6 meters. And since then I've talked to a few people, and there is a phenomenon called Auroral-Es, which seems to be sporadic E, which is triggered by the ionisation from the aurora. So aurora is typically spread by 200 to 300 hertz at 2 meters, and Auroral-Es is not spread at all. On 6 meters, Auroral-Es were worked to ZL, in my case, 2,023 kilometres to Christchurch.
Wow. Okay.
And I worked another station in, forgotten exactly where, but also in centre of New Zealand.
Okay.
There was ZL4LV who worked a number of stations, including, I think, VK7DW.
Okay, Andrew, up north.
And Launceston.
Yep.
And certainly VK3DUT. So, and I am pretty sure all of those contacts were Auroral-Es rather than Auroral.
Yeah.
I have a feeling there was a contact between VK5AKK at Crafters near Adelaide.
Okay.
And Canberra.
Crafers.
Crafers, okay.
Yeah. Yep. Adelaide Hills.
And I spoke to him, and he said he thought it started off auroral, but then the tones
Came right. Yeah. Okay.
So I'm not sure, but I think that was probably an Auroral-Es contact.
Okay.
That was 960 kilometres.
Okay.
So
now that's it. Yeah, because Adelaide to Canberra, he's pointing in the other direction. Canberra's sort of pointing south.
well, I think they pointed at
Southeast.
each other, which I think is also an indication that
It was east.
Auroral-Es.
Well and truly.
Just like the old days of 6 metres, like the
Yeah.
normal
Strategy, yeah.
Wow. Okay.
So, the next slide. Unfortunately, most of the Bureau of Met's Ionosondes are not working at the moment, but there was some strong ease on the Perth ionogram.
Yep.
And if you look at the bottom, it starts off with something about 120 kilometres at the E layer.
Yep.
And then a bit higher up, there is a burst of
The same distance.
which actually reflects multiple times back and forward to the Earth. So it must have been very strong, and I suspect there was something like this going on between us and New Zealand as well,
Okay.
and maybe between Canberra and Adelaide, generating these strong Auroral-Es. Yes.
I think some of the ionograms also suffered from absorption too, so I think the Hobart one just had a lot of absorption
Okay.
below the E layer too, which didn't help. So.
Yeah. The big sweeping line is the F layer.
Okay.
So
Wow.
more evidence that there was Auroral-Es around.
Yeah. Okay.
Next slide. Now, this is a couple of contacts which will just play you. This is what Aurora of VK3DUT.
Now you can certainly hear the spreading on that.
Yes.
That's just
And this is Auroral-Es.
absolutely nothing.
I mean, that was a strong signal.
Definitely. Dear oh dear.
Now, at the bottom, I'll just
Yeah.
this is ZL3RC, which is that very strong signal. It looks a bit spread. It's only spread because the signal is so strong.
Yeah. Okay.
The next one is there's two stations. One is ZL3RC, and the other was another ZL station.
ZL3RC was 4 dB.
Yeah, and I don't think you can even believe
No.
these signal
Once
reports.
it's that strong, it's
Once it's that
exaggerated.
strong. The other ZL station continued on up here,
Yep.
and you can see there's no spreading on him at all.
No.
And then 3DUT is here, and you can't really see anything when the Aurora's there.
Yes. Okay. It's spread out of existence.
But I think we've now got a way of differentiating between Aurora and Auroral-Es.
Wow. Okay.
Next slide. So some of my conclusions, that there are three factors that determine if auroral scatter can be used. One is your distance north. One is the KP index, and the other is the time of day. Even if the KP index is very strong, if it's midday, it doesn't happen. As a rough guide, it seems to be possible to work from Hobart to southern Victoria with a KP of 5, providing around magnetic midnight or local darkness. Even with KP equals 9, it's not possible to work from Hobart around local midday.
Yeah, okay.
And on this occasion with KP 9, propagation was possible up into New South Wales, up to Bateman's Bay.
Okay.
We can confirm that Q65 is an effective mode for scatter. However, it was found that about magnetic, that after magnetic night, it's necessary to use a negative RIT of probably 500 Hertz to avoid missing decodes. A number of stations reported intermittent decoding, which is likely the result of negative Doppler shifts of more than 600 Hertz. The Q65 15C mode is recommended. It's the only digital mode that we've found works on Aurora.
Okay.
And I think we've done all the original work on this here in VK7 and VK3.
Now, that mode is originally a meteor scatter mode, isn't it?
No.
No, okay.
No.
Okay.
Basically, Q65, Joe put in a whole lot of options of both time and frequency spacing to let people
experiment.
I
love it.
And we've been able to experiment and get it to work.
Great. Okay.
Before it was just QRA 64 and you were set at 60 seconds.
Yes.
Set at whatever the mode was.
So you need a wide tone spacing to cope with the Doppler, and because even the Doppler's varying, you need a short period so that at least it's got a chance of decoding.
Okay.
The setup is TX and RX set to 700 Hertz. F tolerance is set to 1000 Hertz because you want to be able to look anywhere.
Okay.
Because you're looking anywhere, it actually does put a bit of pressure on your computer to decode all the possible options over 1000 Hertz.
Yep.
And at least one station had a problem because they were using an old
clunker. Yeah. Okay.
Pedal faster.
The other thing is there's a maximum drift setting which applies a linear correction for drift.
Okay.
Which is very good when you've got, say, a station who's just drifting linearly.
Yeah.
But the Aurora is so variable that there's no point in using maximum drift. I sort of decoded a whole lot of files with and without maximum drift, and it gave about 2% more decodes, but I don't think there's a lot of advantage.
Okay.
And it sort of multiplies up the pressure on you, the effort your computer's going to go to, because it's not only got to test all the way over 1000 Hertz, but it's got to check for a whole lot of drift factors.
When you're running like 15-second intervals, I suppose you'll be 2/3 of the way through the period before it's...
So my belief is you just set drift to zero. There's no real advantage in it. It's going to get you into trouble.
Okay.
Set RIT to minus 500 Hertz after magnetic mid-dry. In the case of the IC 9700, it's just you can set the RIT and then just press a button to apply it.
Okay.
So before magnetic midnight, you just have no RIT set.
Yep.
And if you start to see you're missing decodes where you think you should have gone, you press the button.
Hit the button.
And I think it will work.
Okay.
We don't have many options to check these things again, but we now got a bit of experience that's worth looking at.
Cool.
And your magnetic midnight, well, it varies a little bit across Australia, but in Hobart it's about 1325, 24
Okay.
UT.
Okay.
But as you move in longitude, you can delay or advance that by your longitude difference from Hobart. You can actually calculate this online. NASA has a website called OmniWeb
Okay.
where you can calculate your magnetic midnight for your local.
Cool. Cool.
circumstances.
I'll put a link to that in the description, the video description. Well and truly.
Okay, and this is my final slide, which is the end. But this is the aurora at the tessellated pavements in Tasmania, which I think is a brilliant shot.
Yes. Which got a bit of a go on a few media outlets and a few
Yeah.
websites.
I haven't attributed to anyone because where I got it off the web there was no attribution. So.
Yeah. The attribution, I think, is on a variety of websites. So cool. Okay. We'll head back to here. Fantastic. Thank you. Now we have a few people online. If you've got any questions, throw them in the chat, and we'll try and answer them from the studio. But and we'll keep an eye on that. Thank you, Rex, and thank you, Andrew and Richard. Wow.
That's the next one.
Well, hey, and Andrew, your comment earlier about after the sunspot peak, it tends to be better.
Can be, yeah, that's right. I've seen, I think, thinking back to the early 1970s, there were some really strong events back in about 1972 August. I think that's kind of produced some amazing
August
auroras.
1972?
And that was kind of after the peak of that sunspot cycle.
March 89, August 89.
You can actually be in the wrong spot too during big auroral events. Actually, the March 89 one, I was coming back from Macquarie Island, and you'd think being out in the Southern Ocean you'd have a great view, but the edge of the auroral oval is actually north of us on that occasion, and we were actually kind of inside it.
Yeah,
so
okay.
Kind of missed a lot of the action, but I mean, this is what, if anybody's interested in going to Antarctica, this is what living underneath the auroral oval looks like. So, I mean, it's unusual to happen here, but if you get further south, of course, you tend to see this more often, and you know, can be as spectacular sometimes.
And I assume you get it for longer periods of time, because in you know, midwinter you've only got a certain amount of daylight, a smaller amount of daylight, so you would see it for a longer period.
That's right.
Yeah.
Yeah,
Okay.
Macquarie Island, for example, is right underneath the auroral oval, so you tend to see not this sort of amazing range of activity, but you know, pretty consistent activity most nights.
Yeah, okay.
You just can't really capture it with a normal camera because down in Antarctica the batteries don't last very long.
That's right. Yeah. Well, this is the other
And
thing.
it
you know.
rains all the time in Macquarie Island, which is a problem.
During the
Yeah,
I think
middle of
another
the
guy
ocean.
that VK0DS, the VK2 fellow that's down there's been posting some really spectacular shots, but I think he's gone, sorry they're not very long, but that's as long as the battery will last.
Batteries
Yeah.
last, yeah.
Okay.
Well, of course, this is the thing, you know, back in the early days, you had to wait a week for your slides to come back to see things, and you didn't miss, but it's all instant now, which is fantastic.
Actually, that's a good point. Were they developed down south, or did you have to wait until you came back and then developed?
Developed them down south.
Okay.
Yeah, the old kits, the E6 kits.
Yeah,
and so
yeah,
on, but,
yeah.
yeah.
Oh no, I ran a darkroom at home, so in South Australia, so it was good. I just we'll finish off because we're 10 to 9. One of the things I was just going to mention is I have had the privilege of being asked to go to what's being named up as Exercise Aurora. Surprise, surprise. And we had a bit of a pre-meet at the beginning of this week, and everyone said, oh, it's fantastic that Tasmania could put on exactly what we're talking about as a space weather event. This is primarily a space weather event from an emergency management point of view. So the National Emergency Management Agency, or NEMA, has a scenario which is a pretty scary scenario. We are talking a significant space weather event that takes out things like GPS satellites, communication satellites, and a few other things. So fairly, like,
And power lines.
And and causes issues, ground geomagnetic induced currents in power lines.
Trips them.
In fact, that 1989 event is called the Quebec event because it took out a whole lot of power infrastructure in Quebec, which they took years to recover from. Effectively, just quickly, that geomagnetically induced current causes the ground, so because and jump in here, but the magnetic field is so strong, it causes the ground to fluctuate, that ground level, which you would normally say is at ground. It's not at ground anymore. It actually fluctuates so much that a lot of the protection gear can't cope with that, and obviously triggers, but also it can get to the point where there is so much current being induced in lines, in power lines, that it cooks transformers and does all sorts of things. So, and that was the event in Quebec in 1989. But so there is a scenario that's being put. It is lots of the emergency management areas in each of the state are all descending on Adelaide for 2 days next week to basically go through this scenario and try and work out what emergency management has to do if this sort of event, if another Carrington event occurs. So I'm a observer in this, but yeah, it's going to be a fascinating couple of days, because this is not only how the emergency management deals with this, but also we have a bit of insight into the Space Weather Service, because BOM are a and actually they don't like being called BOM, do they? The Bureau of Meteorology. The Bureau of Meteorology, they did a presentation to us, to the group that's going to be in Adelaide a week or so ago. That's how I got on to this document, and some wonderful little videos that BOM produce about extreme weather events, and also a whole lot of material out of the UK. Fantastic material out of the UK, where they have done a lot of analysis of what it would affect and the sort of risks involved, etc. So yeah, I'm hoping in a couple of weeks' time I can come back and give you a bit of a, I suppose, a bit of a summary on what happened in that particular exercise. So I thought it was very relevant. And yeah, they all thanked us that Tasmania turned on the lights. So anyway.
Yeah, well, we're kind of overdue for another Carrington event. They say it's every 60 years or so, and it's well overdue. But you can see that it's a bit hit and miss. You're just going to have the right sunspot in the right place at the right time,
and not a glancing blow.
That's
not
right.
a sort of a.
Yeah, but it's going to happen.
Yeah. So and we rely on so much infrastructure which could potentially be affected, and things in this exercise, people were saying, it'll knock out all the GPS satellites, and everyone went, well, okay, we won't be able to navigate or whatever else, and everyone started then going, hang on, timing. Mobile phone networks rely on frequency stability, which they get from GPS satellites. And if the GPS isn't there, mobile phone systems.
Although they do have backup.
Oh no.
24 hours.
Correct, but within 24 hours it'll fail, etc., etc., etc. So if those satellites are actually damaged, and you don't turn around and take one off the shelf and launch it and put it back in space. So yeah, it's how that's handled from an emergency management point of view. So anyway, that's our show for tonight. Just finish off with our space weather report, which we've been doing. Now everything's settled down, so we've only got a HF fade out warning, and we've got a geomagnetic warning, which are all very, very low. By today, it was down to an R1, R2 level. So it's possible for HF comms fade outs, and the geomagnetic warning is a G1 chance of a G1, sorry, G0 chance of a G1. So down in the lower end of that. So fortunately everything's settled down. and our bands are starting to come back, and we're getting our propagation back again. So now, just to remind people, June the 5th, we've got Dr. Jim Palfreyman giving us a talk on glitching pulsars, the sequel we've all been waiting for. And then on July the 3rd, we've got Amateur Radio Quiz Night, and on August the 7th, Life in the Lighthouse service with Mike VK7FB. So spent quite a few years in the Lighthouse service and 4 lighthouses around Tasmania. So that should be a fascinating talk. And we've aligned that with August because it is the International Lighthouse and Lightship Weekend. It's not really a contest, but it's a weekend of making contacts with lighthouses and lightships. So anyway, that's what's coming up. Thanks to, we haven't had any questions. So thank you Rex, thank you Andrew, thank you Richard for coming in, and we'll catch you next time. This has been VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night, and 73. We'll catch you next time.